Okay, so welcome to this pre-course introduction for the bachelor thesis course at Linnaeus University. And I am Daniel Toll, and I am your course coordinator. So let me know in the comments if you can hear me. So if you can hear me, write in the comments on YouTube. Be thankful. So today's session is supposed to prepare you for the thesis course during spring. And first, I want to give a short introduction on what is scientific work so that you get some idea on what is expected of you. And so let's imagine that we have a lot of theses from previous years, and also not only theses, also research papers made by computer science scientists. All of these are within computer science, and some of these might be closer together because they are working with the same topic, and some might be further away from that specific topic. So, and computer science is huge and a diverse subject. So if we study this background, we might find what I call a research gap. And the research gap is, something that someone has not really carefully examined, so much so that there is room here for research to be made. So we call that the research gap. And within the research gap, we aim to do what's called a knowledge contribution. And this, I think, is one of the main topics of today, the knowledge contribution, that you are, when you're writing your thesis, supposed to do knowledge contribution to the community of computer science. That means that you need to build on what other people have done, and you need to provide some kind of new knowledge or added knowledge in some research gap to the computer science community. So it usually is some kind of idea that we have, that we do some action. It could be that we are programming something. It could be that we're creating some kind of prototype. It could be that we are comparing a lot of different solutions. It could be that we are gathering systematically knowledge from computer science people, for instance, or we are surveying computer science people. And we are doing something, and whatever we are doing, we're going to carefully evaluate that. And I call that the scientific. We're going to be careful, and the way that we're going to be careful is that we're going to use a scientific method to make sure that we're not so biased. So the old studies, so this one was from someone else, right? And the careful evaluation of our action. Those two things together becomes the new knowledge. And this new knowledge is going to be, provided as background for future students. So this journey is what you're supposed to do. So you're supposed to read what other people have done, find a research gap, and then think about what kind of knowledge contribution can we do in this research gap, and then do some action and do a careful evaluation. Put the old stuff, what other people have done, together with what you are going to do, and then tell the story about that, represented now as the yellow thesis here. Okay, so after that short story, let's go into more, course details. So this is a huge course, and around 100 students, and that means that we need to communicate 100 students and maybe 50 of me and my colleagues that are going to be able to cooperate, right? So, so in order to do that, we need to have a strong communication strategy. So the first part of the communication strategy is the course homepage, and this is for static content. And you can see that it's not my Moodle, but I'm going to create a my Moodle page with a link to this page, so that you can find it. The course homepage contains static stuff that doesn't change between years. And it contains a lot of different material that you can use throughout your thesis. And then we're going to have Slack. And the reason that we have Slack is that we have student groups in Kalmar, we have student groups in Växjö, and we have student groups online taking the same course. So with 100 students, I cannot go to different places and communicate to everyone. I need to communicate in one single way. And the way that I'm going to communicate is through Slack. So there's going to be a channel called 2dv50e. And in that channel, you're going to find important stuff, the dynamic content. You're going to be able to ask questions there. I'm going to be able to provide information and guide you through the course through this Slack channel. So think of this as something that is mandatory to participate in. In the top of that channel, usually I put a number of important links, like a little link to the course homepage. This slide was made 2 years ago, I see, so the schedule, usually I put a link there. And usually I also want you to communicate back to me through Slack. And one way of communicating to 100 people is that when people have read whatever I've done, you make sure that you react on this, or you put a little emote or a thumbs up, thumbs down, whatever, to these. And that way I feel that I'm communicating to you. I know that you've heard what I've said. The post that I pin, you can see that this particular post is pinned by you. That means that this will be a little bit easier for you to find, because the background color of those is going to be different from the other post. And you can also, if we go back a slide, in the top, you can click on this. At 2022, there were 66 pinned items. I guess there are more now. And you can, get only the pinned items, so you can see the important stuff, the important information sent by me. Okay. So I've already said that there are approximately 100 students on this course. And this means that, and then we have 40 or 50 supervisions. And this doesn't necessarily is the same as supervisors, but supervision. So maybe one supervisor might supervise two, for do two supervisions. So this 100 and then around 50 of the supervision and examination is an equation that needs to go together. Then the only way that I can make this equation go together is that all students need to work in pairs. If we allow a student to work single on their own, then we would need to, say no to another student. And I would prefer to, let as many students as possible go through the course. So if we have an uneven number of students, then I will allow one student to work single, and all other students need to work in pairs. There are a lot of students, giving their reasons for working alone. And the only thing that I can say is really, okay, if I accept only you, then I need to refuse another student. And I think that, I think that might be not fair to this student that gets refused because one student. So I think one of the important things now through this pre-course introduction is to talk about this pairing. In order to successfully pair up with another student and write the thesis together, I think that you need to, whoever this is, you need to discuss your grade ambition. So you need to say that I want to aim for the highest grade, or I want to aim for a passing grade. Because if we combine student groups that have an uneven grade ambition, I think that is reason for friction within that group. I think that we can allow two students with a different grade ambition to work together, but we really need to be careful in how we do this thesis work. And if you decide still to work with a student with another grade ambition, I would not recommend it. But if you still decide that we're going to do this, then this needs to be discussed carefully with your supervisor when you get one. Okay, the second thing is that you need to discuss research area, and you might have suggestions for many different research area, and that means that what is the topic of our thesis? What part of computer science lies our thesis within? And if you don't like the same area, both students need to like the same area, or you should not work together. Because it's hard work, this course, and I think that you need to make sure that you both like the subject. So I get a question, is it required to be pairs if you are a project at a company? Yes, it is. So the same thing for all students, despite if you're having external partners in your thesis. The third thing is that if you're going to pair up with someone, you need to make sure that you both can work together at the same time, so you work synchronous. And if you cannot do that, I would not recommend to work together. For instance, if one student is, only able to work on their thesis during weekends, then and the other student cannot work during weekends, then I think that is not a good pair. I think might work as long as you have touching points, and then as much touching points as possible. But don't think of this as two, you cut the work into two parts, and then you divide, I'm going to do this, you're going to do this part. It's actually the way that you need to be a part of every part of the thesis, both of you. So, and in order to have a successful synchronous cooperation, you should schedule your work. So you make sure that, yeah, these are the hours that we can spend on this. And by scheduling your work really, really early and saying that, for instance, Monday and Tuesday, we're going to be fully committed to this one, to this course, and we're going to work together at the library or something like that. Then you have a much higher chance of successful cooperation. And I would suggest that you schedule the amount of hours, at least the amount of hours that your thesis course takes. So there are different tempos, this thesis course. So half time, that would mean that you would schedule 20 hours a week, or full time, that would mean that you schedule 40 hours a week at least. I would say that for this thesis course, for some students, it will take more time than the 40 hours a week. Depends on the thesis work itself. A common question is that can I pair up with someone from a different study program than me? Yes, you can. There are a couple of things that needs to click in order for this to be a successful cooperation. Again, both students need to be registered. So I already told you about how many students there are, approximately on the course, and the high amount of students on the course also means that we have a waiting list of students. So, and I'm going to talk about this on the next slide. So both needs to have their prerequisite courses so that they can be registered. And the second thing is that both need to work throughout the entire time. Even if one student starts in March and the other student starts in January, so they need to at least put, the students starting in March need at least to put a couple of hours each week with the student starts in January. Then, of course, you can, turn up your workload when March comes and you really have time for this course. But if that is the case, really make sure that you're planning this. And if you're joining up with someone who starts in January, be prepared to work during this January, February, March thing. The study problem, or the thing that you're investigating, needs to match your study profiles also. So if you're doing something completely else than your study profile is doing, then if you have not worked with security throughout your study program, and then suddenly you're teaming up with someone who is studying network and security, and you decide to do a network security topic, then one student is the expert in the field and the other student is not an expert in the field, and that is not a good grounds for cooperation either for both students. So, but yeah, I'm perfectly okay that you're pairing up with over study programs if these things match, so to speak. Okay, regarding registration, so previously years, or the last few years, we have not been able to take in all students. So I've made a prioritization list thing to make sure that I am as careful with this as possible. And I just want to show you this prioritization so that you understand my logics behind it. Okay, so a student taking the course in time in their program, that means that you're taking a study program at Linnaeus University, and you're supposed to take the course, for instance, in January. And you have full prerequisites. That means that you've taken all the courses that this course has as prerequisites. Then you are first-hand prioritized into this course. Second-hand is students who are taking the course in time with the program and have almost full prerequisites. This means that maybe there are some points that you're just, from the course that is just starting now in LP2, and you need these points in order to have full prerequisites for the thesis course. Then we will allow you in, but you should almost have full prerequisites. If I need to choose, I will take a student with more prerequisites than a student that is not having prerequisites. And I think both of these things are fair. These points that are on their way in needs to be from examinations made. So if it should not be points that you have not done the examination for, but they could still be examined, so to speak. Yeah. Third hand, we take in, or we let students who have already working on the thesis from this autumn continue with their thesis, so they can continue and they get a little bit of time with their supervisors. This is not an ideal thing that a thesis takes more time than half a year, but it's for some theses this happens. So those are the third hand priority. And then fourth hand, other students. And with other students, I mean first time registration for a new thesis. So if a student has taken the course before and they are now re-registering, but they want to start a new thesis, they are not continuing their old thesis. Maybe they are pairing up with someone else. Or if we have a student that is not taking the course in their time of their study program, then we let them in. And these students need to have full prerequisites. And then finally, if we have a student that is going to re-register for the third time or something like that with full prerequisites, then we would delay those to the fifth hand order of priority. And I hope this prioritization list makes sense to you. And the idea is that we firsthand make sure that students taking program right now can do their thesis. And then, of course, we want to make sure as many students as possible on the course. But it's the cap is actually resources. So it's not me deciding to take 120 or 140 students or something like that. It's actually going to be the number of supervisions I get from management times 2 students that I'm going to allow in. And then I'm going to try to squeeze in as many students as possible. And for that to be fair, I have this prioritization list. Okay, a short overview of the course. So right now, you're starting out with point 1, so to speak. And this should happen, early in before the course. And this is the reason that I give this pre-course introduction now. So where you pair up with another student, you find a topic that you can, work with. And then a couple of weeks into the course, or the first weeks of the course, you're going to get a lot of information from me and workshops and working with me on your topic. And then you're going to create a product called the Student Project Proposal, or the SPP. And this is really a project proposal that is going to be grounds for a decision if this thesis can start or not. So is this a good thesis or not? Can we supervise this thesis? Is this thesis in computer science or not? And when we have one of those, this is going to be a couple of weeks into the course, we assign supervisor and examiner to such an SPP for registered students only. And then when students have their supervisor, then they can work with the slightly more difficult stuff and that would be the methodology of your thesis. And the methodology was the careful evaluation in the first slide. And the reason that we want you to work with a supervisor there is because you have not taken a methodology course, or I assume that you have not taken a methodology course before this. And then when you're gonna present this topic and the methodology to the examiner. So when you have a supervisor, you can work with the supervisor to get the methodology, and when the supervisor is happy with the methodology, you present that to the examiners. And this happens pretty early in the course. And for the autumn course, I should have had one today. That is a bit late. We would like to have it a couple of weeks earlier, but that is the case. And really, this is where you present your project to the examiner before you do the project. So the examiner can say that this is a good project, or this is not a good project, or you need to change your methodology in this way, so that that does not happen in the end of the course when the work is already done, when it's too late to change anything. So I got the question, do we already have subjects we could study rather than finding a topic by ourselves? So yes, I have some guidelines in the end of this thing for this thing, and there's also a list. This list might not be updated though, so it's your responsibility to find a topic. But there are some topics given by supervisors, and there are some topics, provided by companies and such. So I will give you some hints on that. Whenever you have presented to the examiner and the examiner says that, oh yeah, this sounds like a good project, then you can conduct your method. And this is really where you do your bulk of work, right? So this is where you create your prototype, for instance, or you configure your network and do your experiment within this network or so. And then you also collect a lot of evidence or a lot of empirical data. And then you analyze this data and see if that will solve the problem that you're trying to solve, or provides the knowledge that you want to provide. And you write your thesis. And whenever you have a thesis written, or whenever, I would say it's a pretty specific time point, but pretty late in the course, because students are working on all of their work before they start writing. So then we're going to have a short peer review process, so that you are going to give your thesis to another student or other students, and they're going to read it, and then we're going to discuss what is a good thesis. And this is supposed to help both the student who's reading someone else's thesis, because they learn about what is a good thesis for themselves, and then they're also going to get some early feedback from another students on their own thesis in return for that. So whenever that has happened and we have a thesis and it's fairly readable and stuff like that, and I would say like 85% done thesis, then you give your thesis to the supervisor and say that, okay, now we're done with our writing, or more or less done with our writing. We need some feedback from the supervisor. And the supervisor does not have so many hours, so I would prefer that the supervisor only reads the entire thesis once. Of course, you're going to have meetings with your supervisor while you're working on your methodology, and when you're conducting your methodology, and when you're analyzing everything. I want you to have like weekly meetings with the supervisor. But this is the big reading from the supervisor. And then the supervisor might say that, yes, this is good enough for a presentation now, or no, I think that we should wait until after the summer to present this work. And the reason for waiting would be that if you present something, then you can also get an F on this thesis. That would mean that you need to do a new thesis, and you need to re-register to do the new thesis. So I would advise that if your supervisor thinks that your thesis is not done, that you don't present. Because presentation means that you're also going to get examination. So if the supervisor says that, yeah, this can be presented, then you're gonna give your thesis, because that during that reading time, of course, you're gonna continue working on your thesis, and then you're gonna have a presentation where it's gonna be a public presentation, usually in Zoom, and it's usually open to anyone to listen to, the companies, the parents, whatever, teachers, interested parties. And during this presentation, there's also going to be oppositions. That means another student pair is going to review your thesis and read it and ask relevant questions to you during the presentation. And then after that, the examiner reads the thesis and grades the thesis. And that means that the examiner takes over, so sort of gets the thesis and should put a grade on it. Usually this is a multi-step process where the examiner reads it once, makes all their notes, all their comments, change this, change this, change this, gives all the comments to the students. The students take those comments and fixes or, rewrites the thesis according to the wishes of the examiner. And then the examiner gets the new camera ready thesis back and checks that everything has been done and then puts a grade on it. And then the thesis is published and you get a grade for your thesis in the end. So I got a question. Is it possible for the degree project to be done with one student at an employer and one outside? Yes, you can do that. So I'm going to have a slide with, I would be a bit careful saying employer, and instead I would say at the company. But we have a specific slide for companies, so I will wait a little bit with that questions. If I forget it when we're at that slide, remind me. Okay, so we've previously talked about knowledge contribution in computer science, and fortunately, computer science is a diverse subject, right? So I have linked to the Wikipedia page, and if we scroll down over this one, and we get theoretical computer science, and maybe we heard about automata and formal languages and logic circuits and all of these things, and then we have information and coding theory, signal detection, algorithms. So many of you might take the algorithms and data structure course. And then we also have this compiler design and programming languages and formal verification, and we have computer vision, and essentially every course that you've taken that was a DV course was a computer science course. So, and that means that you should have a pretty good understanding on what computer science is. But I just want to, broaden the view a little bit, because computer science is not a super strict thing on what is on this Wikipedia page or not. It's actually a community of people, and these people have a common interest, really. And these people go to conferences and meet each other and write scientific papers about, the things that they are interested in. So computer science can be or is very diverse, which is a good thing, because we got a lot of different possibilities for topics for your theses. But it also means that one computer scientist might have another picture on what is good computer science than another computer scientist. And maybe they don't agree with each other either. So we need to have some kind of test if this is computer science or not. And the test is like this. If your related work, or the most important other people who have worked with the same problem as you have worked with, are published at a computer science conference or journal, then you're going to be okay. Then this is also computer science, we would say. In the end, it's going to be the examiner that checks if this is computer science or not. And in the beginning of the work, I'm also going to try to help you during these workshops with this also, so we can discuss that. So the student project proposal was the first hand-in, so to speak. And we have created a template for this. And the reason that we have this template and the reason that we have a student project proposal is that we learned that some projects fail. And we want to make sure that all the important stuff is in every thesis. So essentially, I've tried to create a template for you so that you can, work on make sure that everything is in there. And first, a challenge within computer science, or a topic within computer science, so that we make sure that it's a computer science knowledge contribution. Then it needs to be clear and understandable. And that is also important, because it's easy to be, fooled by an unclear thesis. And once, when I was a supervisor, I actually thought the student was working on a completely different project than the student was working on, because we did not have a clear and understandable communication. So I could interpret the text the student wrote in one way, and the student interpreted me in some other way, and we completely misunderstood each other. And this should not happen. We need to make sure that it's clear and understandable. It needs to be motivated, and there can be different types of motivation, societal motivation, or research motivation, or economical motivation, or ethical motivation. But really, we need to think about, why are we going to do this? And it needs to be important to more people than yourself. And if you're working with a company, it needs to be important to more people than that company. It needs to be important for the computer science community, really, or some part of that community. I also want to make sure that you have one of the important thing, and that was the background part from the first slide, where we had this the previous works done by other, and these are called the related work, and this needs to be in computer science, and that is one way of make sure that it's motivated and make sure that it is within computer science. So those things are a must. And then it needs to be reasonable for you to do. So you need to have the skills and be able to do this thing. So if it's fantastical construct that we could have a fantastic idea. I'm gonna create one program to solve everything. Of course, I'm not gonna be able to do it. It's not reasonable for me to do that. And we're gonna try to find out, is this reasonable for you to do that? Do you have the background knowledge, for instance? Are you the right students to do that? And then I'm just gonna, you don't really need to read this, but you can see that it's essentially what I said now. And it contains stuff like, okay, if you have started working with some supervisor, if you're looking for a supervisor, if you have a company that you're working with, and then a little bit on the title, and then we're going to have a short pitch, and steps, milestones, actions that is going to happen throughout the work, different risks that you see, and then you're going to write a longer story with the background and motivations. And I try to be as careful in my instructions here as possible. So you're going to more or less fill that in and work with that. And the SPP, is something that some students is going to start with in the beginning of the course, but it could be a good idea to download this and read this even before the course to get a head start, because time is of essence. Yeah, that was something that I think. The SPP is also the ad for your student pair to attract a supervisor, and the ad for your student pair to attract an examiner. So so you want to be clear and you understandable, and you want it to make sure that people or the supervisor wants to supervise your project. Okay, so I talked about the computer science topic, or the computer science knowledge contribution, and many of the theses that we get, for instance, if you're cooperating with a company, they have what is called an application area. That means that we apply computer science to another area of research. For instance, we have had biology researchers asking our students to do theses with them. And that would mean that they are applying computer science to biology. For instance, they listened to bats and the sounds that bats make, these ultrasounds, and then they adopted an algorithm for sound compression, so it worked with this bat sounds instead, or bat noises instead of regular sound compression algorithms that is only working with human audible sounds. So the application area for that thesis was biology, and these bats are birds and stuff like that, and also a little bit of application area in physics, because sound waves are the theory behind sound waves is physics, but so those were application areas. But then, working with the algorithm for compressing this sound data, that is computer science. That was the core of the computer science, and that I call the research area. So everything in computer science, we call that research area. And then when we apply computer science to another area, then that is an application area. And these two things is important to separate a bit, because in the beginning, when students are, trying to work with a cooperative partner, it could be a researcher, in biology, or it could be a company that wants you to create some kind of solution. They almost always want to apply your knowledge. They're not really interested in your computer science research, but your thesis needs to have a computer science research area, and the knowledge contribution that you're going to do, the new knowledge that you're going to provide to computer scientists out there needs to be in computer science research area. The application area, it could be motivation for your work, but it's not what we computer scientists are interested in. So we computer scientists can say, yeah, it's important that we can listen to bats. Of course it is. But really, I'm more interested in how you adopted this sound compression algorithm to make sure that we get these ultrasonic sounds. Okay, so bachelor thesis often has both. It must have a research area. It can only have a research area in some, if you're, in theoretical computer science, for instance, you might only have a research area. So how do we find a research area? And I think that this is one of the things that you could start, or you should start earlier than the course is that you should think about, okay, what kind of courses have I taken in computer science, the DV courses? And was someone of this course more interesting to me? Well, if you're taking programming courses, maybe you dive deeper into programming. If you're taking courses in architecture, maybe you dive deeper in that. If you're taking courses in network, maybe dive deeper into that. If you're taking courses in security, maybe dive deeper into that. And it should be suitable for your study program. Sorry, I'm getting a call and I just need to drop the call. Yes. So one way of knowing that you're, that you are suitable for your study program is that it is connected to one of the courses. So whatever you're doing, it's connected to one of the courses of your study program. This is fairly okay to divert a little bit from, but I think discussing this with a supervisor or so is a good idea. The topic itself, or the research area part of computer science that you're looking to, needs to have research potential. That means that computer scientists should be interested in this topic. It should be, something that has ongoing work within. It's not going to be something that we as computer scientists work with in the 60s or the 70s or the 80s or something like that. It should be something that is, we're currently working with. And one way of looking at that is that when you're looking for this related work, these other studies that other people have done, you can look at when are those published, and if they are fairly recent, within the 10 years or so, then I think that we're okay. The research area also needs to be meaningful for you and your partner in your pair, so that you have the energy to work with this and you have the interest to learn about this, because you need to be an expert in this research area. In the course curriculum, it also says development work within computer science. And that means that, if you've done programming in your study profile, then you should probably do programming in your thesis also. If you've been working with networks and you've been configuring these things, or if you have been working with security, then you should probably do similar things that you've done in your projects, in your labs, in your education, because this was what we prepared you for, right? So I would shy away from the more theoretical work unless you have a supervisor that provides you the idea that we need to do theoretical work in this particular thing. So don't decide on theoretical work yourself. So if you have been programming, to continue programming. If you have been working with security, continue working with security. Yes. And one of the earliest things that I think that would be good for everyone is to find a research paper that someone within your research area has done, that if you had done this thing, you would be really happy. So the closest to whatever you want to do, or that you like. So find a research paper that is closest to you. And in one of the end slides of this presentation, I have some links, and I'm going to release this presentation also, so that you can click on the links, so you can learn how to find these. Okay, the student project proposal essentially is a description of the background and the research area. We've already talked about this. It's going to be a specific part of the background in the research area called the related work. So the related work are the closest works to your own work. They are working on the same problem, or the same, same challenge, or the same similar thing. So if you've created or if you put together an algorithm, and you want to compare that, then you want to compare that algorithm to what other people have done before. So you're going to compare it to other algorithms. So let's imagine that we've done a new search algorithm. You're going to put it next to the other kinds of search algorithm, the insert sort and the insert search. Other kinds of search algorithms. Sorry. It should also formulate your problem, so that we get this knowledge contribution within the research gap, so that we know that, okay, this is the thing that we're trying to contribute. And then it should have a little bit of methodology, and the little bit of methodology is because you have not really you're not experts in methodology. You have not taken methodology courses, so I cannot say that on your own formulate this experiment. It would not be a fair thing to do right now. And I have a link to a paper here that describes why we need a methodology and some kinds of different kinds of evaluations that we can do. But really, the big part of the methodology should be done with the supervisors when the SPP is done. So this is just so that we get an idea of that. For instance, we're going to create a prototype here, or we're going to do a scientific, or we're going to try to do a controlled experiment on networks or something like that. So when we have the SPPs, or I have collected all the SPPs, then I'm going to give that to the list of supervisors, and I'm going to say, okay, you can pick the projects here to supervise. And the supervisors usually try to pick projects that are as close to themselves as possible. And I also allow you to ask for specific supervisors. So you could ask for Jesper, or you could ask for Tobias, or you can ask for me, or something like that. And then when I see my name there, I'm more eager to pick that one, but it doesn't mean that have to be me. You may, during your courses now, or during your time up until the course starts, approach a teacher or a researcher at Linnaeus University and ask, could you be my supervisor? Perhaps you have some idea for some project or so. And supervisors usually are more prone to want to supervise their own ideas than other people's ideas. Many students formulate their own projects, and then the supervisors pick this. The examiners, you cannot choose your examiner, and you should not ask someone to be your examiner. That should be a separate process, completely separated from you. So instead, we need to make sure that the examiner is non-biased, so they are actually going to pick projects that they have and students that they have no relationship to. Okay. Some students want to do their thesis with a company, and this company usually they have some idea of something that they need to have done, or they need to create some part of their project, or part of their product, or part of a service, or something like that, and they want to hand this over to a student. Usually, companies want to get to know you, so it's more or less a job interview that you're doing at this company. But I think that in order to get a successful thesis at a company, we need to turn the tables a little bit. So remember, we need to do a knowledge contribution to computer science. And in order to do that, computer science is, mostly within the academia. But computer scientists are actually working outside of the academia in a lot of these application areas, banking, or, all these different companies. forestry and you know, automobile and everything, right? So we computer scientists are actually interested in how does computer science work in these different domains, in these different things. So we are interested in the constraints of the domains. For instance, if someone is working within banking industry, we computer scientists at the universities are interested in what are the constraints for the computer scientists who are, you know, programming their solutions. What are the solutions that they are using? So when you're out at the company, you're actually from the university collecting information from the company or conducting experiments at the company in their environment, and you're learning about computer science there. So yeah, so you collect data there and you evaluate stuff there, and so think of the thing that they want, and then you're gonna, because if they say, oh, we want you to create this web application, and that web application might be, you know, trivial for computer science, because we have created millions of web applications before. We are not interested in just how to write a simple React application or something like that. We are interested perhaps in the constraints of that specific application area and how that affects our technological choices. So for this particular domain with these constraints, what kinds of technical solutions, or, you know, what kind of programming should we do there? Or if we have several solutions to choose between, can we compare those, which is the best in this application area? Because that is interesting to other computer scientists. They can learn from that and can apply that to other application areas also. So for instance, comparing research area solutions to the application area problems is a way of doing this. And then I delayed the question on, is it possible for a degree project to be done with one student at a company and one student outside of the company? And yes, because the student at the company, that student is sort of the gateway to the company. You're not really, that student is not employed by the company. When you're doing your thesis, you're actually, you know, a student from the university. You're representing the university. You're collecting information from the company, and you're taking their application area problem, and you're trying to, you know, find a research area problem within that, and then we're trying to solve that research area problem. So it could be that you're comparing different technical solutions, and for that you only need one student at the company. Yes. I feel that sometimes the students are a bit torn apart between the company and the university's requirements. So the company might want you to write something or create a solution for something that is more applied, and then we want you to do something that is more, you know, research area wise. And the student, if you try to do both, you might get torn apart between both here. So I think it's important to say to the company, yes, I want to do my thesis work at your place, but I need to do a computer science thesis here. So I need to do some kind of experiment, or I need to compare some stuff in order to work with you. And usually that is not a problem, and usually the thesis work is actually interesting also for the companies. Okay, what should be done now? So I have linked to a YouTube video that I created a couple of years ago on how to search for research in the beginning. So I think that is a good thing to look at. And then this Mary Shaw, I produced the link before. There's also on the course homepage a number of videos created by Jesper on finding a topic, so you can look at those. There is a list of project proposals, and these are not student project proposals. These are project proposals by other people. So these are companies, and these are researchers. And I'm going to click on this one so that you can see, and you get to the course homepage, and then from that you can see the actual. So you can see these are the list of current projects, and some of these projects might be old. So this is not really maintained by me. It's actually maintained by everyone. So it might be that there is a company here that has submitted the project, but the project was done last spring or something, and no one thought about removing it. Just remember that when you're working with it. So, and I don't know either. So, yeah. But this is the place where if I have a project, I'm going to put it here. If I have an idea for a project, I'm going to put it there. And then the 20th of January, it's the first day of the course. It's going to be a literature workshop with the university library. So it's going to be from 8 to 11, I think. The first hour is going to be self-study. So we're going to get some kind of material that I don't know about yet from the university library that you're going to work alone with first. And then we're going to have a workshop in Zoom. And we're going to get a Zoom link and everything on this. I will post that information when I get it in the Slack channel 2dv50e. And I think this is a really good way to start a course, to learn how to search and how to look for information. So final slide, questions. And now I have talked a lot, so you can ask questions in YouTube comments. Okay, what is the criteria to decide that this is enough for a thesis, or I should expand my work further? Okay, this is hard to know. So essentially it's like this. So first you need to get an idea on the related work. Who else has been working here? And then you're within the related work, you're going to get a research gap. And within this research gap, there is going to be many possible knowledge contributions that you can do. And then you're going to try to do the most valuable thing that you can with the time that is given to you. So you don't have, thousands and thousands of hours, but you have a couple of 100 hours. So you need to plan your work and make sure that you do stuff that counts, that is valuable. So it's more or less impossible to answer now, but this needs to be discussed during planning, and you need, usually in the beginning it's too wide, so you're trying to do too much, and then narrower, you try to narrow this down. And this is something that we're going to work with in the beginning of the course also. Okay, is it recommended to get started now, even though the course start is pretty far away? And if so, how far should we go with the project? So I think that pairing up now, 2 students, we're going to try to work together, make sure that you have all these things that, we want sort of the same kind of grade, and we can work together because we both have this and this time. And then start to look into and finding papers within your research area. That is, okay, what kind of course do you like? You ask with or talk to the student that you pair up with. What kind of work do you want to do? I want to do programming. I want to do something else. And then you discuss that, and then you look into the forefront of that and what has been done, what is most coolest right now, and what do I like, what has happened the last time. And from the searching video and also in this workshop in the beginning of the course, you're going to learn more about that. So I think that at least pairing up with someone and try to find that, okay, we want to be within this sub area of computer science. Like, I want to work with software testing, with automated tests, with automated generation of automated tests through LLMs, for instance. So this is the topic that, or the part that I want to work with. So at least that, I think, is a good idea. How far should we go with the project? I think that, the deeper we dive, the better. But some students, they read a paper and they think that, someone else has done this, and then they throw away a really good idea. So I just want to say also that if you read a paper and someone has done what you intended to do, then your idea is a better one than if you don't find a paper that someone has done something similar to you. So it's actually a good thing that you find that other people have worked here. Those are your related work, and you need those. Those is a golden find, so to speak. So then you're going to think about what can I do on top of this. How far should we go with the project? I think that if you, in the beginning of the course, have looked at the different things of the SPP, and you have a research area, and you have someone to pair up with, and you have found a couple of papers that you're interested in and continuing or building your own work on, then I think you've come a far way. What if you can't find anyone to work with? I usually try to create a means of finding someone to work with. So in the beginning of the course, I let out information on how to, talk to other students within within the course and pair up with those. So usually I create a specific Slack channel for, finding a pair. But if you're the single student out, and we have 99 students and 98 of those have paired up, then you can be the single student that does the thesis alone. But I'm not going to start. I can't start 51 projects if I have 50 supervisions, so to speak. So then I'm gonna favor the pair. More questions? Okay, so thank you very much for listening to this almost an hour-long talk about pre-course introduction for the bachelor thesis course at Linnaeus University. Looking forward to cooperate with you on the course in spring. Bye.